Hey guys, my name is Bálint, and today we will introduce you a general extraction process of the PointCloudScene software because we already developed our Wikipedia page and shared some tutorial videos about the software, but you haven't received any real life scenarios about extraction. And today I will extract this junction which you are seeing here. This is a real MLS system dataset. It's pre-classified. It's quite dense. In this small area we have 32.6 million points. It's quite nice dataset actually. We will work with intensity values today, and the main goal is to extract shape using shape files, and yeah, that's it basically. This video is not intended to be a tutorial because we would like to demonstrate how this whole extraction topic works in a production environment, and that's why I will not go into any details about tools and stuff. I will always whenever it's possible I use hotkeys, because we have a extensive set of hotkeys and I'm usually using those, and I will just mention what I'm doing. So this video might be quick for some of our viewers, but I really not aim for a tutorial. It's more like demonstrating how things can be done in PCS. Probably some of you would know better options inside the software already, or would use a different approach, or you would come with different ideas how an extraction can be carried out. Feel free to comment, or if you have any question, just comment as well. We will answer your questions. Sorry. And yeah, basically that's it. And don't forget to subscribe. We will share more videos in this channel in the future. So let's get to it. So as you see, we have a nice junction here. We have some curbs, fence lines, road paintings, manholes, poles, gates, some usual street stuff, you know. And yeah, I will using a shapefile for extraction, and I will ignore attributes because that's the quickest way. If you're interested in detailed extraction using attributes, templates, or you are aiming to extract to CAD, this will be another video at some time later on. And also check the PCS Wikipedia page where you have a detailed manual how to prepare a CAD extraction and how to prepare the templates. But for now, currently we are just going directly into it. So first, I usually please keep in mind I extract using my own personal preferences, which might be different from your own experience or approaches, but that's perfectly fine. Everyone works in their own pace. So first, I will create a shape for the curb lines. As mentioned, I will not use any attributes. The curbs for this current example, I will use only the shapefile. There won't be any special attributes included. So now let's start. I created the shapefile. It's already active. Maybe in group by folder because that's easier, and just go for it. If the trees would be a bothering thing, I can limit the whole thing with elevation or by classification, but that's fine. So I will start with point cloud snap, take the temporal elevation, and then I just go for it. I usually aim for 5 meter vertex distance because that's quite convenient. If you are sharp-eyed, then you also see that I have not used 5 meter. I took longer vertex distances, but that's fine. I will handle this later on. Okay, so first I will extract the edge of the curb and the asphalt. That's the most common approach. I will not go into detail. Yeah, 3D view. Oh yeah, here we are. Nice. so it's under the cloud, but it's not a problem. I will use a drape. Usually for MLS datasets I prefer 5 centimeter drape. Okay, it's shutting over because the point cloud contains a lot of LAS files. I always cross-check the quality. I might add some point size to make sure you see every detail. And I use modify vertex Z wherever it's needed to adjust, because there are some noise somewhere. For example, here you can see there is a gully, and points in the gully can take the drape to the not wanted elevations. Just see. Usually an experienced operator can spot like 2 or 3 centimeter differences from the cloud. Yeah, that's fine. That's perfectly fine. Maybe this one's a little bit too high. Okay, I use modify vertex Z. Okay, so the first line is checked. I will use the parallel tool. Take the line, pick an elevation from the top of the curve, and I just simply shift it 1.5 centimeter. But I already have the elevation. I see that that's not accurate, but that's perfectly fine. I will adjust it by hand. The reason I'm doing this because that's the way how we can ensure that the higher the curve elevation is properly represented, because drape would take us to unwanted places. Oh, sorry, it's too high. Some noise. Okay, that's fine. That's fine. Oh, we need some additional vertex here. Okay, that's perfect. And we need an additional vertex here to ensure that the transfer curve is properly visualized. Okay, that's... You think that this might be time consuming, but I promise it's way faster than use multi-line extraction toolkit. Way faster. Now I have to decide what is the... here I can see the size of the curb. Let's put it that way. This is 12 centimeter, and I don't want to increase the elevation. That's the most common case because the curb is built by standards, so most probably sorry, standard curbstones were used. So that's fine, we have our first curb. That's perfect. Okay, let's go to the other side. Oh, we have some nice car noise, but that's fine. I just simply... Oh, sorry, one more thing. I mentioned that 5 meter vertex shall be used. I use divide section tool with 5 meter distance. I could do this in one step because at the end of the day I can apply this tool to all of the drawing, but for now I just fixed it like this. Here I will go from further, and I will adjust this one later on. I'm not bothered by the cars because the modify vertex Z tool can quickly adjust this. I see it was a little bit inaccurate. You know, as I extract, you may experience that the 2D view of the PCS software might lag. It feels laggy. This is highly depending on the hardware itself and how many LAS files are loaded. We have a tilted stuff here. If I bothered by this, I can turn on the thin display, because then it's way easier to spot. Oh, sorry. Way easier to spot where are we at the moment. But yeah, I will approach like this. Even if I'm uncertain if that's the right way, I still anyway draw it like this, because adjusting it later on is still easier than restarting a whole line. So that's the way you will see. If I have to correct, then I will correct it. That's fine. That's perfectly fine. Okay, and I close it here. Okay. Now, the first thing which I will do is to... How are we? There is something. Oh yeah, we need to drape it. Okay, so first I drape the line. It's slower than usual, I have to mention, because currently we are using a cloud which is very fragmented. like we have a bunch of point clouds even for a smaller area. Okay, that's nice. Okay. Okay. Maybe just in advance I place some vertices to make sure that later on when I adjust the elevation I remove some unnecessary because the distance is too short, to make sure that I'm capable of fixing stuff. Okay, that's fine. These places need to be adjusted manually later on, but the curve line itself is fine. Okay. Okay, so we got bottom line. Now parallel it. I have the elevation and I put it to 1.5. It's a little bit too low, but that's perfectly fine. There are multiple ways how you can fix this, and here I will use a different approach as well. So now, okay, now I see that this is a tilted curve, so I can utilize the photos because we have photos for this data set. So I can say, oh sorry, I have to activate it. So if I check for this place using the geophotos, and I can see, okay, I have the curve, but this is a tilted curve, so I need to drag the line up there, and there will be 2 lines only. Please note that the image alignment is highly dependent on the post-processing, and here we have some misalignment, but if I turn on the cloud and I turn off the image, that you can see it's in the right spot. It's in the right place. Nice and shiny. This one, I move this one. I could fix it into the view as well. It's really up to the user. Maybe make it a little bit more professional. I can lower it down, or even I can do this one. I can just simply move to there, close the curve, and that's it. Okay. Here I remove this vertex, this one as well, and move this to here, and adjust these. Even if a car parks in front of it, it's still visible and it will provide a proper surface then, or acceptable in terms of mapping. Okay, perfect. Well, let's move. In the background, I'm using snap modes, multiple snap modes, about which you can read in the wiki or check the respective video, but I'm using hotkeys to change everything because that's the most effective way. Now, as I see, it's not so nice here, so I will raise this one, change, raise to vertex snap. Okay, change. Where are we at the moment? Yeah, we are here, right? Yeah. For this particular case, I would insert an additional vertex to make it look more professional. Yeah, that's way better. Okay, perfect. Change the self mode. I understand that some of you might say, oh guys, there are a bunch of automated tools in the world out there to extract curves, but according to my experience, and trust me, I'm doing this all day for a very long time, an automation could not handle reality in terms of how people build a curve, how different curve standards are used, how the curve is damaged. At the end of the day, you shall always cross-check and correct it manually in many cases. So it's, even if there are solutions for clear cases, like if you're working on a highway and you say, oh, for a highway it's perfect, and of course the highway is built by higher standards probably, or just used standardized methods, and it's the same profile, same cross section for kilometers of the road, then yeah, sure, it's easier to use some automations. But in real life, in urban scenarios, it's not the case, according to my experience. Of course, you can prove me wrong, but this is the general case. So now I fixed this one. Clear, delete, move. In this case, I append an additional vertex. Move. Okay, this vertex is a little bit low. Okay, perfect. here. I will insert split, move it to there. Okay, I will. Nah, this one is not so nice. It's here. Okay, because I see it's not the best 3-point snap. Okay, it looks much better. Okay, maybe a little bit higher. Yeah. Okay, sure thing. I'm adjusting just a few centimeters, but that's fine. It's up to you that if you want to adjust this or not. Oh, it's clearly low. Clearly on the wrong spot. Okay, maybe this is also too low a little. Okay. And I will ignore this. Okay, that's perfect. So now let's check the image again. Please note that when you say, oh, this software is slow, please consider that I am using a lower config. Yeah, I might adjust this a little bit, but in general it's fine. You can play along with a few centimeters if you really wish to. I mean, if I modify this vertex to here, it's still just 2.5 centimeter or 3 centimeter in 3D, so it's not a big deal. If you ask me, any surveyor can miss this with the GPS, but that's fine, I adjusted it. Or you can do it differently, you just simply remove the vertices and up and again, because then you can ensure that it's a straight line, and that's it. Bunch of ways how you can fix this or that, so it's not a big deal at all. Maybe here it's not the best. Maybe I just undo this. Yeah, it's better that way. Okay, so we have the second curve one. Okay, let's check the third one. I usually use curve extraction to divide the target area to separate parts, because it's way easier to overlook the whole target area if it's separated, like one island of pedestrian path or one side of the path. Now if I finish the curves, I have 4+1 area. I have the 4 pedestrian parts and I have 1 road. So it's easier, because then I can say, okay guys, I just extract the road part of the cloud. I usually recommend to have some boundaries during the extraction, because it helps you overlook. Because sometimes people come to me that, oh, can we load 1 kilometer of point cloud? Yeah, sure. I mean, if your hardware is fine with that and the software allows it, then go for it. But I personally do not recommend, as it's not the best case, you know. I mean, you just simply won't be able to overlook the whole stuff. Okay, here I take a longer line because I have insufficient amount of points here, but that's perfect. That's fine. I will trim it like here. Or maybe I have to check if it's included. Yeah, it's included. Perfect. Then just append it. Okay, drape. Let's see what we got here. So to understand what's going on here. So usually if you work from a single point cloud, it's way faster. I mean, currently if I turn on the show envelope function, there are tiles, and each tile contains multiple clouds. Like here you can see multiple numbers, colors and stuff, which means that there are overlays of point cloud in multiple files, and the software has to check all tiles. So that's why it takes longer than expected, but in general it's quite fast. Okay, I might append the vertex here and remove this one just to make it easier for the extraction's sake. Okay, this is a little bit too high. I drag it to the asphalt level. Okay, fine. You might think that, oh guy, listen, you don't even have enough time to see if something is wrong or not because you're too fast. Yeah, this comes with experience. That's what I usually tell to people, and if you work enough in using point clouds, then you will be aware of these bits and pieces, and less time will be enough to spot issues. I mean, understanding the tool and understanding the clouds is one of the key factors for effective vector extraction, so that's why I always wrong vertex. Try to be as fast as I can, because that's the way. I mean, of course quality is always important, but I do consider I have the sense after 70,000 hours in this software that I can spot differences. Probably some of you who is watching this video, if you get this far, also have the experience in AutoCAD, Topodot, whatever the other software, Cloud Compare, to spot the bits and pieces, the small details. We also had a blog post in our website about the importance of details, so feel free to check that one as well. Okay, this is a bit higher. Okay, here, this is an interesting situation. Let's see how we can interpolate this one, because here we got a tilted curve. Oh, so nice. Let's check this in 2D. So here we have clearly insufficient amount of cloud, and oh, we have a bunch of noise. A bunch of noise. As you can see, this is dust and noise. Oh, that's fine. Now, this is the time when I take the ground. I will info the point cloud, and I see this is class 11. So I will turn off all classes but 11 and ground. This is the 2, as I recall, which will provide me the best result. Yeah. Oh, sorry, I need it in 2D as well. Ground and class 11. Okay. Okay, let's see what we got here. Okay, let's alternative. Yeah, we have no visual on this part. This is something which the laser scanning cannot help of, that some objects are not clearly visible, but that's fine. Let's find a way to interpolate it. I mean, usually in this case I would just send out the surveyor and just make sure that we have the proper position, but in terms of the example we can interpolate, and this is something which I would like to demonstrate. But first let's just move offset vertex this to this, and then like to this and this. Okay, so now, yeah, of course, save warning. I always save. Let's check in Google Maps what's going on. We are here, as I recall. Yeah, we are here, and we are around here. Oh yeah, parking cars, but I see, I spotted it. So this is the point. Oh yeah, maybe just open the this window is tricky. Let's check earlier date, maybe. Nah, this window is bothering, unfortunately. It's a built-in browser and it's just annoying. Yeah, it's around the road painting, so it should be here. Oh, but then it's perfect. Okay. Okay, then this is good. I'm pretty sure I put... Oh, okay, now I can see it roughly. If I increase the point size a little, bit, then you can see it turns here. Okay, and I will just interpolate it like this. Okay, this is fine. Let's check in 3D. Yeah, sure, a little bit of adjustment here or there. Okay, we got it, or roughly got it. Maybe I would say we need to move it a little bit like this. One more vertex here. Okay, this looks even better. Good. Good. And of course the other moved vertices shall be lifted. I will lift this to that elevation up. Oh, it's too high. Okay, this seems appropriate. Okay. Okay, perfect. Okay, now it's good. Okay, the rest is already fixed, right? Right, sure. Now, take another parallel where I can see the... Oh yeah, I can see it here. Let's make it 50. Don't change the elevation. Okay. Also, let's check. Of course, I would be able to do this turn on and off the cloud because that's also helpful. But if I looking from the direction and I see the top of the vertex, it means that it's in the right place. If I don't see it, what I see, let's show you what I talk about. If I don't see the tip of the vertex here, like here or here, then I'm pretty sure it's under the cloud. If I see the vertex itself clearly, like trying to pull off a place like this, if I see the vertex and the lines, that is clearly too high. Even this elevation difference is not so big, it's just 5 centimeter, easy. But even if I'm just trying to slightly increase the elevation to ensure you get a feeling. It's hard. I will highlight this one next time I see it. But even a few centimeter of elevation difference can be spotted clearly. So it's not a big deal if you practice enough to have the right sense. Okay, this side is also done. Let's move on to the last curve parts. Okay, again I have. Wait, I think I just reload the cloud because I just slightly changed. Okay, reload it. So as it loads, you can see its separate tiles are loading, and of course now I'm still turn off the higher points, but that's fine. I won't turn them on because then it's easier to use this classification settings, and that's fine. So new line. You probably noticed that I'm not using tool buttons itself. I mean, I'm not clicking anywhere on the toolbar because everything which I'm using is hotkey based. Of course, the hotkeys could be configured. So even if you have your own preferred hotkey layout from other software, or you think that the default to the software is not enough or not good enough, then you can of course change the layout upon your needs. Yeah, it takes some time to get used to the point clouds. Some sensors, some different sensors have different patterns, some different type of scanners like SLAM scanners and stuff. These are different in many ways. So yeah, there are different scanning patterns, and some data is easier to extract and some data is way more difficult. It's up to you to experience. Usually if you have a sensor specific question, we can answer or highlight some stuff. We also pay attention in oh, this is different. Okay, I make it wrong. Okay, then it's not an issue. I just undo the vertices. This is a separate island. Okay, I will extract this separately. Okay, so now I have the curve. Okay, drape it. Okay, let's check the elevation. Yeah, we have some fuzziness here. Okay. That's fine. Here we will definitely need more vertices. Let's just fix this. Here, okay, I see it. Here, okay, here. Move it here, and I need 2 more. Okay. Sure. Adjust the elevation. Oh, sorry, wrong elevation. Adjust it to the top of the curve. That's good. Okay. Maybe I move this to make it a little bit nicer. Okay. That's fine. Okay, we have an aisle here. I guess if I check the photo, then we will see the same stuff. Yeah, of course, an aisle. A lot of fallen leaves, but that's fine. It's an aisle. Okay. New line. Okay, perfect. And I close this one. Okay, sure. I push a drape. You see this insufficient amount of points, but it's not a big deal, and I see it also at the wrong place. I have to move it a little. Okay, so move using modify vertex Z. That's perfectly fine. I moved it down. Okay, it's done. Let's make the parallel. Okay, 15. For these smaller parts, it's always faster. Okay, and I put it to 15 because 15 is the usual curve size. Yeah, sure, it's already done. Maybe we got some extra vertices here, which I remove. Yeah, sure, we got it. Okay, let's get back to the original curve. Oh, it's a little bit inaccurate here. I will just up and an additional vertex. Okay, sure thing. No, oh, it's quite inaccurate. Wow. I need more. Okay. Elevation is fine. Okay. Okay, let's check the top of the curve. I mean, see, this is an elevation difference of 1 centimeter, but even if you rotate it, it feels not right. So you can spot. The more experience you have, the smaller issues you can spot. This one also feels a little bit odd. It's also 1 centimeter, but that's fine. I usually adjust what bothers my eyes, so it's fine. It comes with experience. More you get used to it, the better your extraction will be. That's fine. It's like driving. More you drive, the better the experience you will have. I mean, it's like there are things which came by experience, and this is one of them that you need to extract more. You see here as well. It's like, I guess, 2 or 3 centimeter. Yeah, it's 3.8 centimeter in elevation, and it's clearly visible. So that's one of the biggest advantage of this toolkit, that the 3D handling is way more fluent than anything else out on the market, or at least which I know. If you can know other software which is as fluent with the 3D handling as PCS does, then I'm more than happy to hear about it. But still, this is very fluid. I always change the rotation center where I double left click, so it's easy to maintain the proper view. and as I don't have to bother with the tools by turning them on and off from the toolbar, and I can use a very fluid hotkey experience, then it's very easy to manage. I'm not sure if it's a sinking curve or not, or it's just tilted. Turn on the vectors. Nah, it's just the curve even disappear. Oh, that's nice. Then I just keep the top line then, because then there is no curve, there is no reason to have multiple lines. I just want to indicate the edge of the road, and that's it. Oh, perfect. Okay, and one more parallel. Here I see it's 15 curve. Of course, it's up to you. There are companies who maintain specific curve tops. You know, it's always up to the company who extracts and how extracts. You know, it's very great variety in this topic. I mean, some company extract with a single line, some company extract with 2 lines the curve, some company extract with 3 lines, so some company pays attention to some details, some are not. The curve extraction itself is a very very big mix out on the market. I mean, I encountered a lot of different approaches to extract curves. Most commonly the 3 line is the best, but if you aim only for a DTM or surface model, then 2 line should be fine, because you just really want to highlight the elevation difference. Okay, now check the middle parts. Nice cloud. Oh, I see that it's bending. Okay, sure. Please sorry my background noises. I'm in home office and I really want to fix this to make sure you enjoy the process. And also, it's not only about the video quality, not about what I'm exactly saying. It's about the look and feel. You have a general idea of what I'm doing and how am I doing it, and that's what important for software toolkits like this. You have a rough idea what's going on. Okay, now this is the tricky part. We have no point cloud, and I will not try to manage this in any way, because insufficient cloud. I can have images, but without the point cloud I won't be able to properly extrapolate, so that's fine. Okay. Yes, we got it. Perfect. Okay, let's make a parallel. Okay, let's adjust the elevation. If I have to. Here is tricky, it's just a little bit lower. I also need to lower these ones maybe a little. Oh, it's very hard. I usually recommend to rotate the cloud with a black background, because then you can make sure that it's good. Sorry, I'm encountering some errors here. Okay, just slightly higher. It's not a big deal at all. I just want to make it look better. Okay, and now I will make a parallel. Oh, it's wrong. Okay, this here. This one is easy. 15 as well. Okay, that's nice. Okay, curve is done, and we have some more curve here. And this is the last curve. Then we can decide where to move on. We are extracting a roughly 80 by 50 meter area, so it depends on if you consider it big or not. I would say I'm not. I'm not considering this as big, but it's possible to think about it as big. It's up to you. Some companies using smaller scale stuff, like using TLS or SLAM for smaller extractions. Some companies use MLS for greater scale, but that's perfectly fine. It's up to you or your company what you are scanning. PCS is fine with any type of data, MLS, TLS, SLAM, ULS. We can handle rasters as well, so it's perfect for an all-around solution. Basically that's it. So it's perfectly fine, and even for freelancers. So yeah, I'm taking it easy right now. I'm not rushing anywhere. I'm just fixing this press drape. Okay, we'll soon move to another topic. So after the curves are done, I think I may move to the road paintings. Okay, here we got some noise in the underground, so I can stop. Okay, good. Up, no, it's not more change. Up, 15. Okay. Yeah, you need to. It's also a common thing to understand. Some companies always want to aim for the highest accuracy as possible, but you know, it's just, you need to consider what are the project specs. I mean, you can play along quite a lot with everything. Every vertex, it can be perfect, whatever, but as you see, you might think that I'm just taking it easy. You would do it more accurately and stuff, but always consider what is the requirement for the extraction, because we are usually aiming for, so it's the most common use case is to aim for mapping purposes, and considering the accuracy category of this noise in the background is so annoying. Aim for mapping purpose, and other companies without laser scanner commonly go out with GPS or with auto station, and they just measure points, and this of course some parts is more or less accurate. Sorry, it's more accurate in some aspects than laser scanning, and some are not. It's really up to, if you using GPS, having 2 or 3 centimeter misalignment in X, Y, or Z, that's fine for a GPS survey because of the nowadays ionospheric effect and stuff. But still, it might not worse to pay attention for some centimeter errors in the cloud, because that's the easier way. Okay, now we got some curves. Yeah, cool. Let's jump in back. So last time I mentioned you with the road paintings, and now we have to go into the road paintings. I considered that polygon would be a good option, but then I realized polyline is a way better option, so I will go for the polyline solution. Extract one object, and then I will copy it everywhere where I need to, and I will make sure that one corner is always on the right spot, usually the top left, because then I will be able to rotate it easily. I will extract some, okay, and rotate it upon need. I don't know which need to be rotated, I have to check. Maybe none of it. Okay, that's fine. That is fine. Copy again. Now this one needs to be. This one requires a little bit of adjustment. Okay, cool. So just copying these nice road paintings. I guess this is the same method everywhere, like you extract something once, then if possible then you aim for reusing it, because that's the way how you can save some time over the work. Sometimes I extract these again because that's the easier, because if it's poorly painted or just simply not visible enough, or it's unique shape or something like that, sometimes it's worse to adjust it by not adjust, extract it manually always. But this is really up to the task, up to the operator itself. A bunch of options available. Yeah, so keep it copy. Okay, I see that this still requires some adjustment. Okay, copy, yes. I'm saying copy the attributes, but practically it doesn't matter because I'm not using any attributes right now because of the type of the extraction. Okay, I have a cyclist painting. Some company has some blocks for this type of road paintings. Some country has standardized blocks, some standardized AutoCAD elements. It's really up to you that what's the general purpose. Okay. So yeah, this is the boring part. This is the boring part, extracting road paintings. Yeah, but this is also a thing which makes the drawing more. I'm not saying shiny, but you know, when clients inspect the drawing, road paintings is something which they are quite easily relate to, and for that reason, road paintings, even if it's low requirement stuff, you still have a chance to deliver something which the client likes, because the look and feel is way better than representing only, I don't know, road edges or axes or something like that. It's sometimes it adds up, but it's really up to the client. You might notice that I don't pay attention to elevation, but that's fine. I will check everything at the end, and I will show you what it looks like. Okay, we are closing to the end. It's also, there is a road patch here, and it breaks the road painting. Some companies aim for extracting the reality, like if there is a patch they would break the road painting, and some company aim for going for the proper representation, because if there is a fixed size road painting there, it should be there even if it's temporarily or somehow damaged by a patch. But it's also changing. It varies company by company. Okay, now extract this one. It's a little bit easier with this multi-line extraction tool. No, I don't want to close it. Oh, sorry. I should have closed it. Okay, no matter. Okay, won't see, not ignore two polygons. This against this. Okay, and this is. Okay, so I trimmed this one. Okay, I forgot to close it. Doesn't matter, I can close it. Time. Okay, now we have one side of the cyclist path. Let's check the whole road. Oh, I forgot. Nice cyclist pictogram. Okay, that's fine. Let's check side road. Side road, as I see, has no road painting, right? No, it's not. Okay. We got some parking. painting here, I will utilize the same tool from here, just simply extract. So as PCS is considered a GIS tool, and we always tell this to our users, that you might not see in spline, arcs and stuff, because it's using points, polylines and polygons. So every arc like shape is split into polyline segments. And I will just align, I will move it like this, so it will be aligned. Okay. Oh, I forgot this pictogram here as well. That's fine. Okay. I have some stuff here. Some road paintings. Okay. And I guess that's it for this side. We have a pedestrian crossing. Pedestrian crossing is tricky, because even if you think this is standard in size, well, I tell you it's not, or at least in Europe. If you think that you can simply just copy it, as it moves forward, it just gets misaligned in some corners, and it always happens. Even in fully straight streets, it just drifts. As you can see, it's already drifted here. So I will rotate a little, just a very little, to slightly to adjust it. Of course, there are many ways how you can extract pedestrian crossing. I pick a simple one by and just simply copying the painting. You see, it's already different in size. Not just the drifting, but in size as well. Okay, that's fine. Okay, copy again. Hope for the best. Oh, it's already drifting. Yeah. So for pedestrian crossing, I usually recommend to just use the rectangle tool, and that's it, because it's easier or convenient, more convenient. Yeah. We are almost there. Still not paying attention to elevation, and I will show you at the end why. Okay, we have a nice bus stop here again. I use the same tool, multiline, extraction to extract this zigzag. Okay. Yeah. Okay, perfect. So now we are on the other side of the road. We have nice cyclist paths still. So I will extract further down the road. Maybe take a better one. I would say this time I come to a stronger place where the cloud is stronger, and extract a symbol. Of course I could copy from the other side of the road, but I picked the lazy approach. Here we have to rotate it. No, this is not looks good. I have to rotate it. Okay. And I will copy this one here, because now I can place it better way. Of course, if the cloud is insufficient in terms of point density, you have to interpolate. I mean, this is this is stuck with the task itself. I mean, everyone interpolates stuff because that's the way how we can deliver drawings in some cases where there is no point cloud. For example, there is a parking car like you've seen before in my video, that the parking car obscures the curb, and you need to use the asphalt elevation. Yeah, I haven't saved this shape yet. It's rotating. I'll write it. Okay. Sure. Then keep on going with the road paintings. Maybe I rotate this one a little because it might need it. Okay, it's too much. Okay, and some cyclist painting. Sure. Now let's move on. We have still some stuff to go. We are soon run out of the road paintings, which is nice. As I think what will be the next, I think I will aim for manholes and valves on the road surface, because this is also a common task. We will using polyline for extracting these, but sometimes, no, not polylines. I'm just thinking what would be the better. You're probably already tired from watching this video. So I might go for point. Let's think about it when we get there. Some companies using blocks for manholes and valves. According to my experience, it's more common than using polylines or polygons for this type of extraction. But some companies still using those. So yeah, blocks are more common. Of course, placing a single point is always easier. I mean, just place a block and that's it, a point, which indicates that it's a manhole, and in the GIS system you just simply assign the proper symbol, or if you are in a CAD extraction, then you just simply use the right block, and that's it. It's up to you or your company culture or the clients. It's really up to you. What do you prefer? I personally prefer blocks because it's way easier. Just put it there, drape it, and that's it. But it's not always it's not always as simple. Let's put it that way. Okay, I'm soon reaching the end of this cyclist path. Okay, we have a nice cyclist symbol here. Of course, cyclist path symbols could be easier with a single block, of course, but for the current video I haven't paid attention for this. I'm also, as I recall, I also don't have any specific block for this type of rock painting, so that's it. Okay, parking spot, nice. Nice. Is there anything else? Let's have a quick overlook. Nope. Okay, so if we check in 3D, as you can see, I turn off. Everything is in a single elevation, which is obviously not good. I mean, sometimes some objects are staying in 2D, in 0 elevation, but for me it will not, so I will just simply drape it. Drape the whole stuff. This might take a few seconds to go over all vertices and all point clouds. As mentioned, if I would have a single meshed point cloud, it would be a little bit faster, but it shouldn't take too long. And after the drape is done, as always, I always recommend to cross-check the drape itself, because you never know if there is any noise, a gully around the road painting, some fallen leaves, whatever. A bunch of stuff can happen during the drape, and just you know, you just need to make sure that everything is in order. You know, that's the main thing here. Yeah, few more seconds, I guess. Then we are ready to go further with the manholes. The manholes will be the next. So yeah. By the way, if you're asking what type of config I'm using, currently this video has been recorded on a i5 CPU, a 4th generation, so it's like due date to exchange it. As I recall, we are a 14th generation or something like that at the time of this video. Also 16 gigabyte of RAM, which is nowadays is not so much, and also using GTX 960. So it's not a very strong config, and I always tell people that it's not needed to have a super powerful PC for extraction itself. I mean, if you post-processing UAV data or post-processing raw laser scanning data, of course it requires a beefy computer, but extraction itself is not. I mean, it's really not. It's not. It's not. Just simply not. We're still waiting. Yeah. I will record a video where you will see that how it looks like when you are using a single mesh cloud, because then it's way faster. You know, the thing what happens here is that the software inspect every vertices and inspect every cloud extent, and from this cloud extent it tries to identify those points which is needed for performing the action, and the more the cloud, the more time it takes to scan everything. Also, if you are using smaller tiles for extraction, personally for MLS or TLS extractions, I usually recommend 50 to 100 meter by 50 to 100 meter, but it's really up to you. For airborne, it can be way bigger. It's way bigger. Still counting. Oh, nice. Nice. While we are counting, I would have a little break, and I come back to you in a sec. Okay, now we are back from our little break. So, as you can see, the drape has been performed, so it's dragged everything up. Now I just have a quick look if everything is right, and as I mentioned before, if you see the vertices can show if something is fallen under or something is bad, like here. It's instantly can be visible that something is not right here. Probably we didn't have sufficient amount of vertex, but that's fine. Just simply use modify vertex Z and I drag it down. Usually edge locations where there is insufficient cloud, it's around the edge of the working area. These are the places where errors commonly found. I mean, of course, considering we are working with a good quality cloud. Now let's check the images, because we are now having some time, and as you can see, and I turn vector on off, you can see we are good. I can look around, everything is in the right place. Of course I can move previous. As you can see, it's good. It looks good. Even if you turn on and off the cloud, you can see there is a minor misalignment in terms of cloud image. So if I turn on the image and the vectors, you see it's fine. So we are good. Now let's check manholes. For manholes, there are multiple approaches. You can just simply inspect the images, or just roll over the whatever was that point cloud and find based on intensity. In our case, I will go over and I will create, how to do it. Yeah, I think it's easier. I will create point. I will create a gully, because gullies are important, separate from manholes. I will create a manhole, and for the sake of clarity I will create a valve, because then that's the easiest. Okay, now we can do multiple things, but for easier approach I will go for the images. I go backwards, I make Kali active, new point, then I place it here. So optically we are placed a point on the image, but it's not true. We are using the underlying point cloud. So in terms of manholes, gullies and valves, it's easier and it's sufficient accuracy. I mean, it's just enough. So I turn on the image, and if you see, it's in the right spot. So that's perfectly fine if you place it using image. Of course, if I want to, I can adjust it, because I see that I could move it a little bit to the left, but I don't think that it's changed anything in most of the cases, especially not if you are building a GIS system. For a CAD system, it might be a requirement to make sure that it's within a few centimeters in the center, but I think that you will have a general understanding what's going on. Okay, let's move on. Okay, maybe I switch to the next. For some reason, some function is not working properly. I can move along with the images like this, or I just simply check where it's questionable. Yeah, there are two waves there. 1, 2. There is a manhole there. Okay, there is one more there. It's a little bit far, so I will cross check if it's the right proper placement. Okay, now I will. Yeah, that's good. Move a little bit to the center using PointCloudScene, but that's fine. Oh, it's a little bit inaccurate because due the angle which I used. Of course, I don't have to use the images all the time, so I mean, I can use manhole, copy this, check if there's any other manhole, but I don't think so. I see the manhole there. Okay, from here to here, and here we got a circular manhole, that's fine. We got a gully, new, check the gully, a little bit low, and I will raise it a little, okay. Now check here, because this might be a valve or something, I'm uncertain. Nope, nothing, that's fine. Let's just quickly roll through here where the intensity and the point cloud intensity is weak. I'm pretty sure I will check, because that's something that I have to pay attention to. Okay, here we got some valves. Okay, and I think that there is no more here. Yeah, we got some manholes. I haven't checked the footway. Oh, there is a manhole, okay. Yeah, this one is barely visible. If I increase some point size, you can see that it's there. but it's not clearly, but I spotted it. We have a manhole here, a manhole here, we have two gullies. So as mentioned, in the future videos we will go into the details of extracting CAD environment for CAD environments, where we pay attention for stuff like rotation of the blocks, display of the blocks and stuff, but for the very moment we are ignoring this one. Okay, there is nothing here. As I recall, this or that might be a manhole. No. Yeah, there are two, three. There are three manholes. Okay. Manhole. New. Extract. 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 Perfect. And I think that's it. Okay. Now we already have the manholes and the road paintings. Now, in this particular video, I'm not paying attention anymore in the road surface itself. If you wish to have an even more detailed road surface, you could use more lines, more whatever surface lines, which you extract. It's really up to you if you wish to aim. You really want to go into the details of the surface. Some projects requires it. It's possible I would add the surface line, polyline, and I just extract some more lines for the surface or generate a lattice. You can read about this stuff in our Wikipedia, but I don't pay attention for this at the very moment. Now I apply all points in the 3D view, because then I would need to see all of the objects. Because now we are moving forward to poles, which would be light poles and traffic sign poles. This is the two things which I will aim for the next. So I will create a point shape for lamp post, and I create a shape for traffic signs. Of course, this could be endlessly adjusted. I mean, we could specify in attributes what type of signs are placed, or I could use a polyline to indicate the direction of the signs and etc. I just don't want to go into that details, but of course, based on what you have seen so far, you probably understand that it's perfectly possible. It's really up to your own needs, that if it's need to be utilized. Now I will play with the snap mode, so I pick point cloud snap, pick the temporal elevation and change to 3-point snap, and pick the center point of the pole, and as you can see, it's in the ground level and it's in the center of the pole. That's the easiest way how you can combine 3-point snap and point cloud snap in order to make this process faster. So again, new point, vector, point cloud, 3-point placement, cross check is there. Okay, there is no traffic sign in this street, but there is one in this side street, then part of the junction. Okay, it's done. Okay, let's check other side of the road. New point cloud, 3-point placement. Okay, so as you can see, it's very easy to just extract on the proper elevation. Just a few hotkeys, some, if you have the right mindset, it's very quick. Oh look, I placed to the wrong place, but doesn't matter. I just simply adjust it. That's it. We have a lamp post and the sign pole a little bit lower. I put the sign post first. This is the bus stop sign, and I will go to the lamp post now. Okay, cool. Now, I have a bus stop here. I just quickly create a polygon shape for the bus stop. If I'm here, I already extracted. Okay. I use a rectangle tool. And pick the corners. And yeah, basically that's it. Elevation is not the best, so I drape it. Perfect. Okay, let's see the middle aisle. Okay, there is some traffic sign. Center around the pedestrian crossing. PointCloudScene, 3-point snap, placement, puff. Go over. Oh, there is a manhole which I missed. Oh, that's nice. I haven't paid enough attention, but that's fine. Dropped it. Okay. The trees and bushes, I will come back to this topic in a minute. Okay, let's check the other side of the road. We also have a bus stop. Okay. Bus stop. From here to there with this size and drape it. You see, insufficient amount of points. No problem. I use modify vertex and it's down. Oh, we have a nice bench here, a separate bench. I will create another shape because if I'm here, I just extract the bench as well. Bench. Save. Rectangle tool. It's not the best. You recreate it because it's not. Okay, sure. Drape it. Okay, I move it down because of the fallen leaves. It's a little bit too high. Okay, we have a lamp post and a traffic sign. A lamp post here. Oh, sorry, wrong shape. Lamp post. New element. Point cloud. 3-point place. Traffic sign. Point cloud. 3-point place. As you can see, it's already in the right spot. The trees I ignore for the moment, including the tree pits. I will come back to this in a sec. We have a lamp post again. New PointCloudScene 3-point snap place. Yeah, right click. A little bit higher. Yeah, that's nearly fine. Oh, now it's perfect. Okay, there is a traffic sign up there. New. Just the car. PointCloudSnap. 3-point snap place. Off. Done. Traffic lamp post on the other side. Lamp post new. PointCloud 3-point place. Right click. Okay, perfect. Traffic sign a little bit lower. PointCloud 3-point place, right click. Okay, that's very good. This is some building poles. Okay, we have a lamp post in the corner again. PointCloud 3-point place, right click. Okay, nice. We have an advertisement board. Okay, I create a polyline for this one because advertisement objects might be linear, not polygonal. Like advertisement. Okay. Okay, in this case, the 2D view is insufficient, so I will pick the 3D. So I pick this point, and this point. I drag it down, pick the lowest elevation, and it's not exactly accurate, so I had to adjust it with modify vertex Z. Slightly over, just slightly. Okay. let's move on. There we have some noise and a tree. Okay. Now we have pose and stuff. If I turn on the cloud, you can see we got more shiny objects and getting more. Now I will create a 3-bit layer. It's also polyline because we have some 3 bits. In terms of this extraction, I'm not using surface edges. I mean, I'm not paying attention to surfaces in terms of if something is asphalt or something is concrete or stuff. First thing first, I append vertices to the curb because I want to make sure that I can connect my lines. It's already further down. Okay, technically to trip it. Okay. And then I just simply extract the 3-bit in 3D view. That's it. That's it. Perfect. Now trees. We could utilize the tree extraction toolkit. We have very nice tools to extract the trees itself using the extraction toolkit, which is designed to extract the main geometrical features of a tree in a semi-automatic way. But this time I just simply paste the points. There are video tutorials about this, and it's also described properly in our Wikipedia page. So currently I'm going for a simple solution. 1 3-point and the other 3-point. And of course I haven't checked the elevation, but I have to adjust it in the center point. Nice. Nice. Oh, we have some sign here which I missed. Oh, nice. It's not. Okay, perfect, it's done. And we have some trees in the middle. I don't want to forget those ones as well. It's a little bit more complicated, but there are other ways as well. So I might just say, okay, I pick this point. Where is it? Oh, here. Then I can identify the tree. Where is it? Where are we? We are here, and I drag it down. Okay. It's fine. So I can do this if I want to. I mean, I can just simply place a point around the location where I know there will be a tree somewhere around the trunk, and then I just simply go there and adjust it afterwards in X, Y, and then drag it down using modify vertex Z later on. So there are a bunch of opportunities as well. Of course, the tree extraction toolkit would allow you to precisely set the base point of the tree. It's also possible. Okay, sure. There are no trees. And here we have 4 more trees. We have one in here. One in here. It's barely visible, but I guess this is it. Yes, nearly, because you got a traffic sign here. Of course, I usually perform the cross-check of the whole extraction at the end of the extraction process, because that's the point that where it's easier to go over with the images. Move this a little bit further up because the pole is bending. Okay, that's fine. And we have 3 more trees. which I would like to place 1, 2, and 3. I cross-check the elevation, of course. Okay, that's nice. We have some hedge, and of course if I want to I can create a polygon for the hedge, but because I would like to demonstrate some surface building at the end, I will ignore this step because I don't want to go into that direction right now. Okay, we have some other stuff going around: building, fences and gates. This topic can be also adjusted, like bunch of approaches exist, you know, hard fences, soft fences, metal fences, concrete bases. What do you consider fence? If you consider a gate as an entrance, endless possibilities exist, but for the sake of this extraction I will simplify this. I will have a layer for building, and I consider stairs, steps, everything to this. I have a fence, I will create a fence, and I will create a gate, because these are the most common approaches, you know. And of course, pedestrian and vehicle gates are considered the same from this aspect. Okay, let's go from this point. You can extract in 3D or 2D, whatever you prefer. This time I will go for a hybrid solution, so I will start from here and I will go from gates. Gate start. This is a gate, and I will perform the drape instantly to make sure that the connection is fine. Okay, I will have some fence until here. I drape this single vertex because the other one is already draped. Another gate. Drape it. We have a small part of fence from here to the building. Of course you can go into more details, of course I can. Even if I want to, I can manage this gap, jump in, but it doesn't matter. Most in 90% of the cases no one would care for this jump in. I mean, you can generalize it, it's not a big deal. And I will do this as well in order to proceed faster. And now we are having a nice building here. Oh, we have a terrace. I will consider the terrace as part of the building, just for simplification. So I see that here we have the terrace, and then we have some other terrace and some steps. And of course I can adjust this. I drape it. Basically that's it. I have a nice building line, fence line, whatever. So it's basically the back of the footpath. I will ignore these small poles, the overhang, stuff that can be extracted, but from our perspective at the very moment it's not as important. Okay, let's come to the other side. We have a nice gate here. So we start with the gate. Nice, drape it. Cross check the drape, it's too high. Okay, that's better. Let's go with the fence. Of course, as mentioned, I can extract it right here. I mean, that's also perfectly fine. I might use more vertices, but still this is also perfectly fine. If you see that in 2D it looks nice as well, so it's up to you really how you would like to proceed. In some cases it's easier to do it in 2D, for some objects it's easier in 3D. It's really up to you. and it will develop over time. I mean, using PCS, as mentioned before, requires experience, and you will learn how to excel this. Okay, maybe I put a new vertex here. Move, please. Corrugate. Okay, that's fine. Now I extracted using 3D view, so I'm not even have to use drape because I know I extracted. I use modify vertex Z because I see that there are leaves around, so some vertices might not perfectly align with the in terms of elevation, so I just correct it a little. Okay, we have a nice gate. Okay, move it down. Perfect. Go along with the fence. Now I come back to the 2D view because it's even easier, because then you just bring a straight line. As I see, it's not the best way because it bends. So there is a small arc, but that's fine. Now I use modify vertex Z for a quicker fix. Okay, that side is also done. Let's check the other. It's just some gate and pure fence. Of course, I can zoom in more to make sure my work is more accurate. Whole bunch of clouds. Of course, I go only for public areas, but if I want to, I can go into the gardens and stuff, because the trees and some objects, buildings are also visible there. Of course, if you are using an airborne data, then it's up to you what you would like to extract. So it's fine. I will cross check. I will simplify this here. I will drape this one, and I'm sure I will cross check if everything is right, because at the end I was a little bit uncertain. But let's check it. It's not an issue if something is not good for the first try. You can always adjust. But it seems okay now for me. Maybe this bus stopped a little bit too high. Yeah, a little bit. Oh, that's fine. Fence a bit lower. Okay. Okay, that's good. And have some gate at the end. Some gate. Okay, that's good. And on the other side we have fences, gates. That's good. What we're starting with? Fence. Okay. Just carry on with the extraction, and of course I will cross check if everything is good or not, because I will drape it. But it seems okay to me. We have some gate. We have some fence again. This might be considered a building, but I will keep it as fence to make it pretty. I append this vertex because that would help a little. Okay. That's private property. It's up to the user if we really need to go into this place or not. But for the demonstration purpose, I will go in. So I go in with the fence, going in with the gate. I use modify vertex Z to make sure that everything is in the proper elevation. I save because I would like to make sure that everything is saved. Fence up here. We got some gates again. Okay, we got some gates until there. Okay, and we got some fence to the end. I open the vertex to make sure it's good. Okay, and basically we are done. Yoo-hoo. This is a simple extraction example. So now we save everything and let's go further because I would like to demonstrate a few more stuff. So I will now create another polygon and I will call it a boundary. A boundary is usually required for building surfaces. So that's what I would like to achieve, because now every point and line is properly set in 3D, so I could use everything to build the surface. So now I will build the surface using all the line, but for this I will fence everything to make sure that the surface area is fine. So I just simply trace. There is no actual trace tool, so I use vector snap and I just go over the place to make sure I include all vertices to the boundary, because the boundary shall be 3D as well if you are building a proper surface model or contour map or something like that. Okay, now we have the boundary. Now let's build some surface and let's check how it looks like in a triangulated model. So I'm checking my triangulator. I have a frame shape. I have some break shapes. I have point shapes. I give everything. I round it and I go for start building it. I got it, and as you can see now I have a nice triangulated surface. I load it to 3D, and as you can see it's nice and shiny. Of course I could append more surface lines to the road or extract more points from the road surface to ensure that we are good, but still we have a nice surface. And from this surface, which I also save because I would like to keep it for later, we can generate a nice contour map. I will go for a whatever 20 centimeter contour, and I will go for minimum 0 to 300 because we have to specify the range, and I'm uncertain at what elevation we are, but sure, this will be very fine. And now it's already generated because it's quick. I also save this one, and I turn off the triangulation and just turn on contours, and as you can see we have a nice contour map of this whole place. And of course this can be combined with point cloud, but of course this density of the point cloud is not proper for the purpose which we are aiming for, but still you can go for it. So yeah, and now everything is saved, and we can go to Quantum GIS, and in Quantum GIS I'm able to append all of these shape files, and then it's awesome. Because we will select all shape files. The shape files, and you will be able to see that everything which we created so far, everything is in, of course, in a proper projection because we were in Hungary. I have to set, because the software does not set the PRG file, the software ignores the PRG file, so upon first opening in a GIS system you might need to assign the proper projection, so I will assign it now. As you can see, we have a nice and shiny map here in Quantum GIS based on what we extracted in PointCloudScene. And as I recall, we spent less than 2 hours in total to get to this result. And of course, we can get more details, more surface points, more surface lines. We could place surface identifier points to identify asphalt or soil surfaces or whatever. But I hope you get a broad understanding what we are trying to achieve here. So whenever you would have a project where you would need some point cloud extractions, consider the PointCloudScene, and we hope that you get a better understanding now, and it's not as dry as a Wikipedia or a manual, because now you see what is possible to reach with PointCloudScene. And of course this video is not describing all the functions, the features, the possibilities, but over time we will upload more and more videos, and we hope that you will find what you are looking for within our software toolkit. So thank you for your time, and again please subscribe and watch more tutorials and more upcoming videos on our YouTube page to learn more about our tool. Thank you.